Hello students, in last video we have seen how to get the transfer function from vertical system, that is vertical mechanical system. Now this system is horizontal system. This system is exactly same, only I have drawn it horizontally. The rules are same. What you will do, first look at this mechanical system. Okay, so additional component is Fc1 and Fc2. This Fc is called as the friction coefficient. In last video I have shown you, if we are applying force on the duster, there will be friction between the surface of the duster and the surface of the paper, or the surface on the road also, if we are talking about the car. Okay, so this component is only Fc, but force because of friction is same as that of force because of damper. How we are writing the equation for force because of damper? This is Bx dash of t. Okay, so instead of writing B, what we will do, we will replace that B with Fc. So the force because of friction, it will be Fc x dash of t. Okay, now in this numerical, in exam it can be asked like this, just to draw the free body diagram, or second can be asked to write differential equation, third can be asked to find the transfer function. Okay, so in last video we have seen how to get the transfer function. There are two choices. Suppose it is directly asked to find x2 of s upon f of s, so you need to obtain equation for x2. Okay, suppose it is asked to obtain transfer function x1 of s upon f of s, so you will obtain the equation for x1 of s. Okay, now look at this, as here number of mass is equal to 2, so there will be two free body diagram. Okay, so from where you will start with the mass m1. Okay, so I will draw free body diagram here. See, this is free body diagram for m1. Now see how many components are connected here. 1, 2, 3 and 4. For mass m, including mass, 4 forces are acting on m1. Okay, and one more force, that is the externally applied force. Okay, so you have to show the externally applied force same as given, that is f of t. Okay, so remaining forces will try to oppose the applied force. So first of all, force because of m1, I will write m1 x1 dash double dash of t. Next, force because of spring. Okay, so this will be kx. Force because of this damper. This damper is common element, but initially it will try to oppose the applied force. So this is the direction of force because of B12 on M1. So how I will show B12 x1 dash of t minus x2 dash of t. Okay, then one more force is left, that is force because of friction. This force because of friction is not a common element, that is in between the rigid contact and the surface of the wheels. Okay, but that force will also try to oppose the applied force. So I will show Fc1 x1 dash of t. Okay, so 4 components are there, and force because of these 4 components will try to oppose the applied force. So this is free body diagram for mass m1. Okay, now we will draw free body diagram for mass m2. Okay, so what is input force? Input force on m2 is force because of damper. Okay, look at this, here I have shown the direction. So for m2 it will be in opposite direction. Okay, here I have shown b12 in this direction, so here I will show force because of b12 x1 dash of t minus x2 dash of t. Okay, look at this, only I have changed the direction, I have not written here x2 minus x1. Okay, so you have to take care. Now next, how many components are connected to m2? First of all, force because of m2. So m2 x2 double dash of t. force because of K2, so this is K2 x2 of t, force because of this friction, so Fc2 x2 dash of t. Okay, so how many components are connected? 1 2 3 4. Okay, so I've shown 1 2 3 4. What is left? Yes, all 4 components are on mass m2. Okay, now look at this. These are 2 free body diagram. What you have to do? From free body diagram you have to write the equation. Okay, so from first free body diagram you will write first equation, f of t is equal to m1 x1 double dash of t plus b12 x1 dash of t minus x2 dash of t plus kx, here it should be x1, kx1 of t plus fc1 x1 dash of t. Okay, so this will be your equation number 1 from first free body diagram. From second free body diagram, input force is x1 dash of t minus x2 dash of t is equal to m2 x2 double dash of t plus fc2 x2 dash plus k2 x2 of t. So this is your equation number 1. Okay, so we have obtained 2 equations because 2 masses are there. Now what is next step? You have to take Laplace transform of equation number 1 and 2. After taking Laplace transform, you need to take care what you have to obtain. You have to obtain transfer function. Okay, so from first equation you will get f of s. Okay, from second equation you have to see what you have to obtain. If it is x2 of s upon f of s, so you need to obtain x1 of s equation. If it is asked to obtain x1 of s upon f of s, so you have to obtain equation for x2 of s. Okay, so simply see, there is a rearrangement after taking a Laplace transform. It will take some time, but your arrangement should be thus should be in standard form. Okay, so this is only for getting the transfer function from mechanical system. Okay, so you have to do the practice, okay, for the mechanical system examples. Okay, thank you students.